Number 1, solve the equation sine 2x equals 2 cosine 2x for 0 degrees is less than or equal to x is less than or equal to 180. Okay. And you look at this and you think, oh my goodness, where am I going to start? But think about the 2 trigonometric identities you've used this year. To solve an equation, you either want it in sine or cosine or tan. Okay? So, can we do that? Yes, we can. Divide both sides by cosine 2x. And therefore, we have, what is sine over cosine? That is tan. So now we've got tan 2x equals 2. And now, we can say 2x equals the inverse tan of 2. Now, we could just update, if you like, this here. This is for x, right? What about for 2x? It'll be between 0 and 360. Pointed. Okay. So, let's find out what this equals. So they've got 2x equals our first one is 63.4, is it? Okay. Now, if we think about our tan graph, it's going to look something like this, isn't it? Where this is 0, this asymptote is 90, this is 180, and this is 360, and 270 is our other asymptote there. Yeah? We found one here at 63. There must be another one 180 degrees later, so you go 180 plus 63 using symmetry. Should give you the second one, so we'll have 63.4 and 243.4. Super job. We're almost there. What are we going to do as our last step? Divide by 2. Both of those by 2. So you get all of your results in the line for 2x in this range, and then you divide by 2 to get your final answer. So therefore x equals 31.7. And next one? 121.7. 121.7. And those are our answers. The next thing we have to prove is an identity for number 5. This was one of you was talking about identities. This was actually using an identity as well, wasn't it? But the next one, we've got to prove this identity. So we've got tan x plus 1 over tan x is equal to 1 over sine x cosine x. So we've got to get from here, left-hand side, and make it into that. Now, if we're going from tans to get sine and cosines, we probably want to change our tans. That's probably our first move. So I would say, next, what's tan x? That is sine x over cosine x plus. Now, this one will be 1 over sine x over cosine x. So far, so good. But another way of writing this, you think of 1 divided by 1/2, right? That goes up to there, doesn't it? So another way of writing this is sine x over cosine x plus cosine x over sine x. Okay? Now, we want to have a denominator of sine x cosine x. So what could we do when we've got something like this? Cross multiply, yeah? So this one will be sine x times sine x. So what's that going to be? Sine squared x over sine x cosine x, and to get this one to be this denominator, we've got to times by cosine x. So this will be plus cosine squared x. But wait a minute. What's the top? That is 1. So that's 1 over sine x cosine x. And we've proved this. So we used both identities that we learned in that one question. Alright, now part 2 of this question says solve this equation. I'll move over here. What's the equation that I meant to solve here? 2. What does it mean, Preet? 2
over sine x cosine x equals 1 plus 3 tan x.
Okay. Now, often in Cambridge, the first part of the question helps you solve the second. So we've proved this here. Yep. We've proved that that is the same as this. So what if I've got 2 of these? It would be the same as 2 of this. And then we've got everything in tan x, which means we can solve an equation because we want it all in one, right? Right, so that's what we're going to do. This must be equal to 2 bracket tan x plus 1 over tan x. And then on the other side of the equation, we've got equals 1 plus 3 tan x. Does that make sense? We all good at this point? Yep. Let's expand out our brackets. So we should have 2 tan x plus 2 over tan x equals 1 plus 3 tan x. Now, a really good thing to do at this point. This is annoying, isn't it? So why don't we times both sides by tan x, which will get rid of this, won't it? So times this, so this term will become 2 tan squared x. When I times this term by tan x, I will get 2, so plus 2. When I times 1 by tan x, I will get tan x. And when I times 3 tan x by tan x, I get 3 tan squared x. And now what do you notice? This is like a quadratic. So we bring everything over to this, to the right hand side. So we'll have 0 equals tan squared x. Because 3 tan squared x take away 2 tan squared x is tan squared x. Plus tan x minus 2. Is that okay so far? Okay. Hopefully we haven't made mistakes. I think we're all good. Now, we could factorise this to solve it, couldn't we? Can we see that? Tanaka, what do you reckon we could do? Tan
x plus 2 in brackets, tan x minus 1.
Yep, I agree. That'll give us a positive 1 tan x. Okay, so therefore we've got 2 ways to go here. Tan x equals either negative 2 or tan x equals 1. Okay, now we've got to solve for those. So x equals the inverse tan of minus 2, which equals minus 63.4. Okay. Now, did they say anything about where they want this? It's got to be between 0 and 180. So this is 0, this is 90, this is 180, and we've got a negative 63, which is over here because that's negative 90. Do you see that? So we actually just want to add 180 to get this one here. 100 and
166.5.
0.6? Yeah, okay, that's what I get to. Alright, so we've done that one. Are there any others in the range with this result? No. Okay, now we're going to do the next one. So Tiadia, this would be x equals the inverse tan
9,
Mm-hmm.
which is 45.
Okay, now we can use the same diagram again. 45 is here. Is there anything else within the 0 to 180 range? No. The next one is just over 180, isn't it? Okay, and those are our two results. We're trying to prove that tan squared theta minus sine squared theta is equivalent to tan squared theta times sine squared theta. Okay. Okay, what did we do first here? We're doing identities, we only know two. We could use tan as sine over cosine, or we could use sine squared theta plus cosine squared theta equals 1. In this, what do you think is most likely to lead us to victory? I reckon we want to change this one, because we don't really want a cosine squared theta in here at all, do we? No. Alright, so maybe we should do this. Well, let's try a step and see what happens. Sine squared theta over cosine squared theta minus, and we're going to do sine squared theta cosine squared theta all over cosine squared theta. Is this helping us? Times by, gave this the same denominator. Okay, so we can just leave it like this, right? So we can go sine into 1, sorry, sine squared theta into 1 minus cosine squared theta. See, sometimes when you just actually push ahead, sometimes you doubt yourself, but if you just push ahead, something will become clear. We're there. We are, aren't we?
Oh, yes.
Right? So 1 minus cosine squared theta is sine squared theta. So this is sine squared theta times sine squared theta over cosine squared theta. But this over this is tan squared theta sine squared theta. So the hardest step was obviously going from here to here, I think.